Hey guys, so we are going to go ahead and start with the first section of Chapter 8. As I'm starting here, I just do want to preface this with, I've never actually made a video like this, so if it sounds weird or if my handwriting sucks, I apologize, so please just bear with me. But let's go ahead and get started. I'm just going to bring out my, inner YouTuber that never existed. But we are going to be talking about polynomials in Chapter 8. And that's basically any of these expressions with multiple terms in it, with like x terms and x squareds, even x cubed, as you'll see down here. But let's start with this one. So for factored form, as you guys know, that means we are going to want to do box and diamond. But before we do box and diamond, I want you to notice that there actually is a common factor that we can pull out of here. If you look closely, you'll notice that all of these terms can be divided by 2. So we can actually rewrite this after we pull out or factor out a 2. So we can say, okay, well, it's 2, and then 2x squared turns into just x squared because we divided out that 2. 2x turns into x. And negative 12 divided by 2 is just going to give us a negative 6. Okay, so this is our new version of that. It's just going to make it easier for us to graph it and then factor it. So now that we did that step, we can go ahead and do the box and diamond that you guys are super familiar with. This box is going to be a little rough. Okay. So as usual, remember we're focusing on this piece right over here, not the original problem. So our first term goes in the top left box, which is x squared. Our third term goes in the bottom right, which is negative 6. And we need to figure out what goes in these other two boxes. So we are ready to go ahead and do the diamond now. So the top of the diamond, remember, is first term times the third term. So first times third, that's going to give us a negative 6x squared, and the middle term goes in the bottom of the diamond. I'm going to go ahead and write 1x, even though it just says x, just so you guys are clear that there is a 1 to consider there. And now you get to play the game. So what two numbers multiply to make the top and add to make the bottom? We'll notice that that's going to be 3x and negative 2x, because 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So now that we know that's correct, we can go ahead and fill in the rest of our boxes and use that information to fill out the outside. I'm kind of just going through this a little bit quickly because we've already done this many, many times. So as we go to rewrite this in factored form, you guys might be inclined to just do what you're used to, which is this. However, please don't forget that we just factored this piece right over here, so don't forget about that 2 that was there. We still have to keep it. So this is going to be our factored form. Technically, that should be a f of x. Right, so now that we have our factored form, we know that, from previous chapters, when you have your factors and set those equal to 0, those are actually your x-intercepts. And so we know that our graph, our parabola, is going to hit our x-axis at positive 2 and negative 3. And just take the opposites there. So we got positive 2 right over here, negative 3 right over here. And that's about as specific as I'll require you to go on the graph for now. Of course, your y-intercept is going to be actually at negative 12, so this graph is going to be pretty long, but we're just going to go ahead and make a little sketch here. This is going to be a little rough. But, alright, so that's our sketch of our graph. So it's not super new stuff, but the new stuff is kind of going to be now. It's a lot of vocabulary. So when I ask you for the degree of a polynomial, okay, that's going to be talking about the largest exponent on an x term in your polynomial. So when you look over here, you're like, I have an x and I have an x squared. Which one of those has the biggest exponent? Well, it's going to be this guy, and that exponent is the degree. So I know that because it is a 2 on that term, my degree is going to be 2. And that's because it's the highest exponent. Okay, so that's a degree. All right, the next vocabulary term here to keep in mind is a coefficient. I think we've probably talked about coefficients before, but what that's going to be is the number in front of your variable. So every term that has some kind of x in there has a coefficient, and that's the number in front. So the coefficient here is 2, the coefficient here is 2. This number on the end is a different vocab term, so that one is not a coefficient. So for us, our coefficients are 2 and then 2. They're not always going to be the same, so just keep in mind that they're only both 2 because both of these happen to have a 2 in front of them. And we can say here, just take a note, that these are the numbers attached to our variables. Okay. So that brings us to the leading coefficient. So this is also a number attached to the variable, but the thing about the leading coefficient is that it is going to be the one attached to your degree term. So while both of these have coefficients, your leading coefficient comes from the term that has the x squared, because that's the term with the degree. So basically, it's the coefficient on the term with the highest exponent. For us, that is still going to be 2. Just know that it's this 2 and not the second one. So our leading coefficient, again, is going to be 2. It probably would have been better to have an example without same numbers, but again, just keep in mind what that really means. And we'll make a note here that it's the number attached to your x with the degree. I'm just going to write with because I don't have a ton of space. Number with the degree term. That brings us then to the constant term. So a constant term is the number that doesn't have, or I guess the term that doesn't have any variable in it. So these two have x's in them. This one, this little negative 12 is just hanging out by itself, and that is what we are going to call our constant term. Because it's just a number, it doesn't have any variables with it, so it will never change. It will always stay constant. Term without a variable. Right. So your constant is never ever going to have an x associated with it. So this next example is actually a cubic function. If you'll notice, this has an exponent of 3 rather than the 2 that we're used to. And so this factored form, you guys aren't really familiar yet with how to factor cubic functions, but there's actually a trick to it that we can use our calculator for. So let's just go over here to our calculator, and we can go ahead and type it into our y equals. So let's just go ahead and type our x cubed minus 13x squared, oops, minus x plus 13. Okay, we got our x cubed minus 13x squared minus x plus 13. Let's see what our graph looks like. So the thing you have to be careful about, now remember, factored form always, well for now, as far as we know, shows us the x-intercepts. Just like in this example over here, we knew based on these factors that our x-intercepts were going to be at 2 and negative 3. So here, we can tell that there's going to be x-intercepts right here, so we already have an idea of what some of the factors will be. However, the fact that the degree is 3 tells us that there actually should be a third x-intercept. That's something that we'll talk about even more in detail a little later, but it's something to keep in mind. The degree tells us how many x-intercepts or roots that we're going to have. So this isn't quite showing us everything, so I'm going to go ahead and go to the window, and I'm going to make it show me more values on my x-axis. So I'm going to say the maximum number on my x-axis, I'm going to go ahead and change that to, let's go 18, see if that helps me at all. So that just shows me the x-axis up to 18. So if you see, now I see all 3 x-intercepts on the same graph, so we can use our second trace function to find them. All the way from chapter 1, if you click on 0, remember those are pretty much the other name for your x-intercept. So we're going to go ahead and play that left-bound, right-bound game. So on the left, we're going to find this intersection first. Go to the right of the intersection. It disappeared, but we know we're somewhere to the right. Press enter, enter. It tells us that we have an x-intercept at negative 1. So right over here, we're like, okay, one of my factors must be x plus 1. Remember, we always take the opposite. Okay, and here, we could do the same thing, but because we're in like a pretty standard Zoom format, you can see that the other one is going to be just at positive 1. So we can say that another factor is going to be x minus 1. You just got to take the opposite there. Now for this one, let's just go ahead and do our second trace menu again. Go to 0 and play the left-bound, right-bound game. Just go until you can see your cursor show up anywhere to the left of your intersection. Alright, so the cursor's struggling a little bit here, but this is going to be on the left. I know we can't really see it because this is such a steep line, it's going to be really picky about it. We'll go here, and then we'll go farther to the right. And you can also count the tick marks. Remember, if you're in like a standard Zoom, you can count the tick marks, and you'll find that this intercept is at 13. So our final factor is going to be x minus 13 because we have an x-intercept at positive 13. Alright, and if we are to sketch our graph, we're like, okay, there's one at negative 1, positive 1, and 13 will be all the way over here somewhere. For simplicity's sake, we'll just stick it right there. And kind of just, imitate the graph you see on your calculator. It's not going to be perfect by any means. Mine is especially going to be a little rough, but we're just gonna let that go. So again, this is really ugly, but you get the point, hopefully. All right, so now this portion is just like we did above. This degree of the polynomial is going to be the highest exponent on an x. So for us, that's going to be this term right here, and the exponent itself is 3. For coefficients, it's the number in front of all the terms with an x. So here, our coefficient, there's just going to be an imaginary 1 wherever there isn't a number, so like in these two spots. So we know we have a 1, we have a negative 13, and we have a negative 1. Our leading coefficient belongs with the x cubed because that's the one that has the degree in it. So 1 is going to be our leading coefficient. All right. And then our constant term is going to be 13 here because if we look at our problem, 13 is the number with no variable. So our next example here, as you can see, it looks a little different from our other ones. This one's actually already in factored form for us as opposed to the other ones being in standard form. So when you're trying to take factored form and put it into standard form, you actually have to multiply out all of these factors. Now that wouldn't be so much to ask if it was just like 2 factors, maybe even 3, but multiplying out 5 factors is kind of a pain, and I'm not going to have you do that. It would just kind of be an outrageous amount of work for this, so we can go ahead and skip that. Okay, and then the degree of the polynomial isn't so bad to find. That one, even though we're in factored form, all we have to do is take a look at how many x's are going to end up being multiplied together. So we know we have 1, 2, 3, 4, 5 x's, which is going to cause us to have a term of x to the 5th if we did multiply it all out. And this tells us that we have a degree of 5. We have 5 x's being multiplied, our degree is 5. All right, and then coefficients is another thing that is much more convenient to find in standard form. You can't really tell what it is here because you need to combine like terms and everything, so we're not going to worry about that either. And lastly, for coefficients, the leading coefficient, we actually can find that. When you're in factored form, you want to look to see if there's any number in the beginning before all the parentheses. And here we don't have anything, so we can just go ahead and assume that there's a 1 there. So we know that our leading coefficient is a 1. And the constant term, it's really obvious in standard form, but again, it's not too bad to find in factored form. All you have to do is take like the constant term on each factor and multiply them together. So that tells us we have a negative 2 times a 2 times negative 1 times positive 1 times negative 5. And if you multiply all that out together, negative 2 times negative 1 times negative 5, you should end up with a negative 20 for your constant. All right, so now that we've taken care of those pieces, we are ready to make our graph. The nice thing about factored form is it's the most convenient form to be in when you're trying to draw a graph, because these already tell you right away what your x-intercepts are going to be. So like x minus 2, that factor tells us that we have an x-intercept at positive 2. Remember, you got to take the opposites. Okay, so similarly, x plus 2 is going to tell us we have an x-intercept at negative 2. X minus 1 is going to tell us we have one at positive 1. X plus 1 tells us there's one at negative 1. And then x minus 5 tells us there's one at positive 5. So the only thing left to do is draw in our curve, and the problem here is that we don't actually know like what the shape is going to look like. We don't know if it's going to come down or start at the bottom and go up. And so the best way for us to figure that out is to just go to our calculator, and you're going to go ahead and type in your equation to at least just get an idea of what the shape is of our graph. So just type in exactly what you see. Do not miss any parentheses. I made that mistake a couple of times today. X plus 1. All right. It looks like it should be right, and then you're going to go ahead and hit graph. And this is our shape. It looks like a super funky graph, but it gives us the information we wanted, which is that it started at the bottom and then it came up. It like shot out of the bottom. So we know that it starts at the bottom and then we know it ends going up. So our graph, and again, I apologize, this graph is going to be no better than the last one. This tablet thing isn't the greatest for drawing graphs. It could be worse, right? It's not so bad. And that is our final graph. It's a reasonable sketch. At least we know what the x-intercepts are, so we can get that part accurate. And then you're all done. You have a general idea of what your graph's going to look like.